I'm Mike AD, and this is Math AD, where we combine calculus and alcohol for unpredictable results. Cheers. All right. I'm about to prove that alcohol and math can go wrong. Don't drink and derive. So, today we're going to do some derivatives instead of integrals. We're going to be doing a derivative, but not the conventional way. We're going to be doing a derivative based on first principles. And first principles means that we're going to be using the definition of the derivative to derive the answer, to show that the derivative of x squared is 2x. So, today we're going to start with f at x, your function of x is equal to x squared. Okay? Now, the definition of the derivative would be f prime at x, which is the limit. And if if you hate limits, then you're going to really hate this shit. I hate fucking limits. Okay? No limits. So, it is the limit as h approaches 0 of the function fx plus h minus f at x all over h. And this is pretty simple because everywhere that you see the function x squared, you just add an x to it, and then you follow the equation. Okay, I'll show you exactly how this works. So, f prime at x is going to equal the limit as h approaches 0 of this function x plus h. So, x plus h is x plus h all squared minus x squared all over h, right? So now we're just going to divide this through, see what happens. Okay, this is going to be equal to the limit as h goes to 0 of x squared plus h squared plus 2hx, right, minus x squared all over h. Okay? Now, this x, that's gone. So let's simplify. So this is the limit as h approaches 0 of 2hx plus h squared all over h. You can see the h's here. So what we're going to do is we're going to take out common denominator and we can get rid this denominator, okay? We're going to take out a common factor. It's going to be h, which equals 2x plus h all over h. Two h's cancel out, and so that the limit of h goes to 0 of 2x plus h goes to 0, and your derivative is 2x. Now, we can do one that's a little more complicated. Actually, let's do that. Let's try that. But before we do that, let's take a drink. Oh boy. Let's do another quadratic. Since these are great. Something like this. X squared plus 2x plus 1. So, we're going to have our definition of our derivative. This x right here, every time you see x, it's an x plus h. That squared plus 2 times whatever you see is there. X plus h plus 1 because there's no x. Now minus whatever's in here. X squared plus 2x plus 1 all over h. So forgive me, I'm going to spend a little time just to expand this quadratic over here. So this is going to be x squared plus 2xh plus h squared. We're going to move the 2 into here. We're going to get 2x plus 2h plus 1. Then we're going to expand this part. Negative x squared minus 2x minus 1 all over h, of course. Don't forget that this is the limit as h approaches 0 of this whole bloody monstrosity. Okay, so we have our x squared, that comes out. We got our plus 1, that's convenient, that's gone. We got our 2x right here, that's gone. Oh boy, what do we have here? Okay, let's simplify this now. We got the limit as h approaches 0 of 2xh plus h squared plus 2h all over h. Right here, we're going to take out a common factor in the top and see if we can make the denominator go bye-bye. So we got a limit here. We'll take out the h at the top. We get 2x plus an h plus 2 all over h. The h's cancel out. So the limit as h approaches 0 of 2x plus h plus 2, this h goes to nothing, and this equals 2x plus 2, right? And if you look at this original function, the derivative of this is 2x plus 2. So guess what? We didn't do it wrong. So this is how you go about doing this kind of first principles thing for quadratics. When you're trying to do stuff with cubics and higher functions, my God, you're going to be there for a long, long bloody time multiplying stuff out. But them's the breaks when you want to torture yourself. So, I mean, talk about torture. Leaf fan here. This is why I drink, buddy. So, join me next time when I'm more intoxicated.